In this exercise, we show that a sequence, which is recursively defined, converges, and then we find its limit. Our strategy is to use the monotone convergence theorem, which states that any sequence that is both bounded and monotone converges. So we're going to show that it's monotone increasing by induction. S sub 2 equals this expression by our formula. When we plug in the value for S sub 1, we get 8/5, which is greater than 1, which is S1. Therefore, S2 is greater than S1, establishing the basis for induction. Next, we're going to assume that S sub k is less than S sub k plus 1, and then show that that implies that S sub k plus 1 is less than S sub k plus 2. So, starting off with S sub k plus 1, using the formula, and then using our inductive hypothesis, we show that the expression with S sub k is less than the same expression with S sub k plus 1. And then this is the expression for S sub k plus 2, therefore showing that S sub k plus 1 is less than S sub k plus 2. Therefore, S sub n is less than S sub n plus 1 for all n by induction. Now we're going to show that the sequence is bounded above by 2. Clearly, this is true for S sub 1, establishing the basis for induction. Now we'll suppose that S sub k is less than 2 for some k. Then S sub k plus 1, using the formula, and then using our inductive hypothesis, this expression is less than the same expression with 2 plugged in. This equals 9/5, which is less than 2, showing that if S sub k is less than 2, then S sub k plus 1 is also less than 2. Therefore, the sequence S sub n is bounded above by 2 for all n by induction. Now we've shown that it's monotone, so it's always increasing, and the first value is 1. It's bounded above by 2, therefore the entire sequence is bounded by the interval 1 to 2. Hence, and this is the monotone convergence theorem, we have shown that the sequence converges. Since it converges to some value which we call S. Now the limit of the sequence S sub n is going to be exactly the same as the limit for n plus 1 for very large n. Therefore, we can use the formula to find S. S is going to be the same as S sub n plus 1. So using the formula here, these two values are going to be the same. And then a few simple algebra steps leads us to the limit, which is 7/4.